Hello, welcome to my channel, The X. Have you ever wondered what the difference between buoyancy, density, and gravity is? Well, let's set sail on a journey to unravel these intriguing concepts. First up, we have buoyancy. This is the force that allows objects to float, whether on water or in the air. Picture a ship sailing across the ocean or a hot air balloon soaring through the sky. That's buoyancy in action. Next, we delve into density. Think of density as the mass packed into a specific volume of a substance. Imagine a bowling ball and a beach ball of the same size. The bowling ball is denser because it has more mass packed into the same volume. Finally, we come to gravity, the mysterious force that keeps us grounded. It's the force that attracts two bodies towards each other. It's the reason why when you jump, you always come back down. Understanding these concepts individually will allow us to discover how they interact and differ. And that's precisely what we're going to do. Stay tuned. Scene script. Let's dive into the concept of buoyancy first. It's the force you feel when you float in a swimming pool. Imagine you're in a swimming pool, effortlessly floating. The reason you're not sinking to the bottom is buoyancy. It's a force exerted by a fluid, such as water or air, that opposes an object's weight. In simpler terms, buoyancy is why some things float and others sink. Now, to understand buoyancy, we need to take a brief detour to Archimedes' principle. This ancient Greek scholar discovered that an object submerged in a fluid experiences an upward force equal to the weight of the fluid it displaces. So, if you've ever wondered why a massive ship made of heavy metal doesn't sink, it's because it's displacing a volume of water that weighs more than the ship itself. But it's not just about ships and swimming pools. Buoyancy is everywhere. Ever noticed how a helium balloon rises in the air? That's buoyancy in action too. The balloon displaces air that weighs more than the helium inside, causing it to rise. It's important to note that buoyancy isn't about the object's weight or shape. It's about the weight of the fluid displaced. Whether it's a pebble or a gigantic ship, the principle remains the same. So, buoyancy is all about how objects interact with the fluid they are in. Now let's switch gears and talk about density. It's a measure of how much stuff is packed into a certain space. Imagine you're at a party. If the party is in a small room with, say, 50 people, it's going to feel quite crowded. But if the same 50 people were at a party in a large hall, it wouldn't feel as crowded. This is somewhat analogous to density. Density is essentially how much matter is packed into a given volume. The calculation for density is quite simple. It's mass divided by volume. So if you have an object and you know how much it weighs, its mass, and how much space it takes up, its volume, you can calculate its density. Let's illustrate this with an example. Suppose we have a kilogram of feathers and a kilogram of steel. Both have the same mass, right? But feathers take up a lot more space than the steel. Therefore, the steel is denser than the feathers. Density also plays a key role in determining whether an object will float or sink. Imagine dropping that kilogram of steel into a tub of water. It would sink, right? But if you drop the kilogram of feathers, they would float. That's because the feathers are less dense than the water, while the steel is more dense. Density then determines how much space an object takes up relative to its weight. Now let's leap to gravity. It's the invisible force that keeps us grounded. Imagine you're holding an apple. When you let go, it falls. Why does it fall? That's gravity at work. It's this force that pulls two objects toward each other. And the thing about gravity is it doesn't discriminate. It pulls everything with the same force. Whether it's a feather or a hammer, if dropped from the same height, they'd hit the ground at the same time. But gravity isn't just an Earth thing, it's a universe thing. It's the force that pulls the moon toward the Earth, keeping it in orbit. It's the force that keeps the Earth and other planets in our solar system circling the sun. Now, how does gravity work? Well, it's all about mass and distance. The greater the mass or the closer the objects, the stronger the gravitational pull. That's why you feel the force of Earth's gravity more than the moon's. Earth is much bigger and we're much closer to it. But remember, gravity, doesn't just pull things down, it pulls all objects towards each other. It's just that Earth's gravity is so strong, it pulls everything towards it. So when you jump, you come back down. Gravity, then, is the universal force of attraction acting between all matter. It's the tie that binds the universe together, making the cosmos a waltz of celestial bodies. Now that we've gone over buoyancy, density, and gravity separately, let's explore how they're different and how they interact. First off, buoyancy, density, and gravity are all unique concepts. Buoyancy is the upward force exerted by a fluid that opposes the weight of an immersed object. Density, on the other hand, is a measure of mass per unit volume. Gravity is the force that attracts two bodies towards each other. Now let's delve into the interconnections. Gravity and density both play pivotal roles in buoyancy. Think about it. An object will float in a fluid if it's less dense than the fluid itself. This is because the fluid, being denser, is heavier and gets displaced, creating an upward force or buoyancy. And what decides the direction of this upward force? You guessed it, gravity. It's gravity that pulls down on both the object and the fluid, setting the stage for buoyancy to play its part. So, you see, these three concepts are like the three musketeers of physics. Each has its own role, yet they work in harmony to create the world as we know it. From why ships float to why we stay grounded, these principles are at work. So, while buoyancy, density, and gravity are distinct concepts, they work together to shape our everyday experiences. Let's quickly summarize what we've learned about buoyancy, density, and gravity. Buoyancy, remember, is the force exerted on an object submerged in a fluid, causing it to float or sink. Think of a rubber duck in a bathtub or an iceberg in the ocean. Density, on the other hand, is the mass of an object divided by its volume. A denser object will sink, while a less dense one will float. Imagine a stone and a piece of wood in a pond. Now, gravity is a force that pulls objects towards each other. It's why the stone sinks to the bottom of the pond and why we don't float off into space. These three concepts, while distinct, work together in our world. Buoyancy and density determine whether an object floats or sinks, while gravity pulls them towards the center of the Earth. Understanding these concepts can help us make sense of the world around us, from why boats float to why we stay grounded on Earth. Thanks for watching. Please subscribe for more interesting videos like this. Have a nice day.